right, thank you. I'm glad to see everybody's here this morning on the last day for the last session, especially after last night. Hope everybody had fun. All right, so my agenda. First, I'll give you a little company bio, a little bit about myself and Biogen. Talk about the differences in IT/OT. That's kind of been explained. I won't go too detailed on that anymore. You've seen a lot of that. I'll go through two specific use case scenarios that we've had where we've had to build this relationship with IT in order to get some of these new projects moving along. And that'll include kind of giving you the scope, the challenge we were faced with, the solution we came up with, and the business benefits that came out of that. Lessons learned will be focused mostly on what I learned collaborating with IT. Usually we don't have a close relationship. We've been pretty closed off. So a lot of things came out of these two projects that we learned moving forward. So Biogen, through cutting-edge science and medicine, Biogen discovers, develops, and delivers to patients worldwide innovative therapies for the treatment of neurodegenerative, hematologic, and autoimmune diseases. Some of the big drugs we have now, which you might have seen, Tecfidera, Tysabri, or MS drugs. New one, Spinraza, for SMA. And recently in the news, you've seen a lot of Alzheimer drugs. That's currently got us a lot of stuff in the pipeline for that. So to put this in context, specifically, I work in they call the drug products. I don't know how many people in here are familiar with pharma. There's drug substance, which produces the API, or active pharmaceutical ingredient, and that gets shipped to us. In drug product, we take that, add the excipients, and then do fill finish. So essentially put it into vials or some kind of pill form. I specifically work in the fill finish site myself. And I'm an automation engineer, been with Biogen for about 5 years now this month. What is IT? Same as you've seen before, pretty much any business side system, they generally don't interact much, if at all, with your process. ERP systems, in our case, Oracle, EAM, same thing, email and internet, cloud, HR, finance. None of those things are really process critical. Don't touch your process side at all. Stay mostly on the corporate side. OT, operational technology, kind of a new buzzword for me, I guess. They kind of keep us in a box, but so anything that actually does touch your process, your PLC, SCADA, DCSs, any sensors, process batch data, typically segregated on its own network. In my case, Biogen is a heavy user of Delta V, their drug substance sites. At drug product, where I work, we deal a lot with Wonderware. So that's a lot where both of these two use case scenarios take advantage of Wonderware. And the key here, obviously, is convergence. We have years and years of data sitting on our production side systems. We want to be able to get that out, and from what I've seen in a lot of cases here, that works in a two-way scenario, right? You get that out onto the business side, and there's a lot of value you can create sending data actually back down as well. But we're kind of just scratching the surface, so the primary focus was to initially, how do we get this data out, and then kind of work from there. So I've heard a lot about data-driven analytics since I've been here. Obviously, you want to integrate with the business side. You want to get all that data out. The specific challenge we had that kind of drove this was production planning came to us and said, we need you to increase your production capacity. And we said, okay, great, we can do that. The two things you generally think of, the first thing, well, hey, can we get some new equipment that's more efficient, reduce our cycle times? They said, no, that's a big CapEx expense. You can't do that. We're not giving you money for that, sorry. So, all right, well, can we hire more on the operations side, pay overtime or whatever? No, that's a big OpEx expense. Can't do that either. So what do we do now? So we came up with this plan. Well, let's see how we can optimize our existing process a little bit. We've got 8 years, 10 years of data, production data, real-time sensor data, alarms, events, everything sitting on our OT side historian that hasn't been touched by anyone or analyzed by anybody. So that was the idea with this is, eventually we get into the point where we can do real-time analysis, machine learning, predictive simulations, stuff. I actually added that, I don't know, a month ago when I was working on this presentation, just as something I thought that, was still 5 or 10 years out. And since I came here, it's my first time at this conference, seeing people actually using a lot of this data for, machine learning and predictive analysis is amazing. So that was real interesting. So, implementation. This is essentially, from a high-level standpoint, what our plan was. We took our process data that gets sent to our Wonderware historian. That's been an existing system. Nothing changed there, right? So what we had to do was get this data up to our business side, and Biogen standardized through all their sites on Pi. So after getting that data up to the Pi historian, what do you do with it, right? Business applications. In this case, for this specific scenario, we had to model our entire production line. I think it was called Pro Model. So we used, cycle times for each piece of equipment. If you're not familiar with, fill finish line, things go through equipment like parts washers and autoclaves. They have cycle times. Same thing with the fill line. So one of the key components to doing that was, again, optimizing to see where our bottlenecks were, where we could improve some of those processes based using our existing workforce without adding. Maybe we can run some in parallel, things like that. Maybe we can work on operator shifts to make things more efficient. So some of the benefits that came out of this by modeling our entire process, using this data that we got from our OT side, we were able to increase our production capacity by eliminating these bottlenecks by about 30%. So as I said, a lot of it was analyzing cycle time and how operators are running equipment, what they're doing in sequence, things that they can do in parallel. So we increased that production time using the same workforce numbers. We didn't have to increase those numbers at all. We didn't have to extend anyone's hours. Created like a work shift schedule based on the results of this. And also adjusting the PM schedule, so your preventative maintenance. That's a big key when you're running production, and they don't want you to stop the entire year. And so by kind of stabilizing that schedule based on these models, we're able to work in preventative maintenance, more sessions of preventative maintenance to keep us from going down. All right. The second big project that I worked on was real-time inventory tracking. So typically, what I've seen before in pharma was you'd get, before you start your production process, you go through your ERP system. You get a pick list of all your materials that you're about to use on your line. A lot of that is then tracked via paper. So as things are staged in your warehouse and moving through your process, people are tracking it on paper, writing down quantities, where they're consuming it. We track things like sterility. Something comes out of an autoclave, it's got an expiration date, or a parts washer, same thing. So we thought, well, why not take advantage of the system we have, all the technology we already have on our OT side, to do electronic tracking of all the materials through the process. And this is essentially what it looked like afterwards. So on the Oracle side, or your ERP side, it would create, and we used XML files for doing this. You'd get a bill of materials in XML format. You get a PO, process order, to include all your batch data, your finished goods, what number you're expecting, what the materials you're expecting, and your material inventory, which is all the physical items that end up being staged in your warehouse prior to production. So all that would be automatically sent down from Oracle to our Wonderware MES system in XML format. And then the MES system would pick that up, and as they're staging materials for production, they'd create a barcode. So this barcode contains all the history of that material, where it came from, what its sterility status is, quantity. So it's kind of like a physical to virtual match. So as they're moving things through the facility physically, they're also doing it virtually. On a screen, they can see, okay, this tube is in compounding, or this tube is in component prep. Yep, I can see it on the screen as well. And they do the same thing as they go through production. They're consuming materials. They're doing it electronically on the HMI. So at the end of the procedure, what happens is we generate called a consumption summary. So everything they use in their process that they went in on the screen and clicked consume gets summarized in one file. Same with production summary. Your actual finished good, which should match your PO, both of those files get sent up to Oracle, and then it then automatically subtracts that from their inventory. So typically you'd have a giant stack of papers, if you weren't doing this, that someone would have to go through, sit in front of an Oracle terminal, and kind of, one by one go through and subtract out your inventory, which adds up and takes weeks. Since you've actually done your production, it can be weeks later since when you're actually doing that process. So this cut down a whole lot of time and a lot of transcription errors. I think I do that in the benefits, yeah. So definitely a decrease in deviations from material tracking errors. And I say deviation, that's a farmer term. Anytime you deviate from your process or deviate from some known value, a set point or anything like that, that's a big deal. You have to investigate those pretty in depth and close them out before you can actually ship your batch. So no more manually tracking things by hand significantly reduced those transcription errors. And then you have a decreased risk of low inventory scenarios. So you're not waiting 3, 4, 5 weeks for someone to manually go through and update these values in Oracle. It's all done automatically. So when you hit a low inventory scenario, they can automatically order new material and you're not waiting for it. So getting into the lessons learned part. This was the first time that we've really had to build a relationship with IT. We typically have not worked with them before. It's been a pretty segregated network physically. I've heard the term used, air gap. They don't touch each other at all until now. So there were some good things that we learned out of this, how IT can help us on the OT side. A couple of those, networking and hardware administration. My background was mechanical engineering, worked my way into automation to the OT side. I'm not a networking guy by any means. I don't have Cisco certification or anything like that. So network topology is not my thing, but that's where IT can really help you out. A lot of that design and administration, preemptive troubleshooting tools, things they do on the IT side, you can do that on the OT side, and that's also part of hardware. Just keeping track of things when before you have major servers go down, things like that. Stuff we kind of tried to do on our own, but we don't have the best tools because we didn't know what the best tools were. They helped us out with that a lot. Efficient network design. As we start to see the increase of a lot of these IP devices, you start getting a lot more traffic. You have to worry about, subnets and running out IP addresses, things like that. So that was another area where they're much more knowledgeable than we are. And then security, seen a lot of that here, cybersecurity, antivirus threat detection. Again, not something that on the manufacturing side you usually have to deal with. It's a little bit different on the ICS side, but they have really good starting points on how to deal with that kind of threat, or at least locking down your system before you have to even get to the hardware or software side. But there were things to watch out for. Some of the problems, I shouldn't say problem, but opportunities for improvement, if you're familiar with Six Sigma, but OT requirements can be vastly different from IT. Our process data is deterministic, and I'll kind of give an example. IT is not. So on the email side, you send an email, it's going to go through at some point. It may take 5-10 minutes. If it doesn't, you can resend it, that type of thing. On our side, we can't recreate process data. So if I'm measuring vial weights and collecting that data into my historian, if for whatever reason the network is down and I don't capture that, I can't go back and get it again. It's gone, and it's gone for good, and that creates a problem. So that was one of the main things that we had to kind of sit down and talk about. System updates, things like, I'm sure if you've connected your laptop, you VPN'd in, you'll get some kind of notification. They're trying to push an update down. You have 60 seconds before your computer restarts. Not a big deal on your corporate laptop. On your server that's running your Wonderware or Delta V, that's a big deal. You don't want to be rebooting systems in the middle of production. The same with patching operating systems. Some security patch comes out, that's the first thing they do is usually install it and push it down. Those have to be vetted very carefully and tested, and not just for Windows, but for these custom applications you're running on your servers. For example, Wonderware typically will wait for them to test major security patches before you implement it. And there was that recent one that they warned about actually using because it caused issues. Same with antivirus and firewall. They like to use active protection on the IT side. And we've seen instances where some companies might actually have their own cybersecurity on the IT side that doesn't even talk to IT itself. So you'll find areas where they don't know why things are being blocked because there's a completely separate group that's hidden that's doing it. So you can't do that on the OT side. That's where you have to use passive, and we've seen a lot of vendor solutions for kind of passive anomaly detection. Oops. Did I miss a slide?
Where's IT? What you get before the blue screen.
Exactly, yeah. That's karma right there. Okay. So, some of the key points, if I was going to give anyone who works in automation on the OT side some advice, get your IT group involved early. It's better to start that relationship sooner rather than right before you have to execute a project. They're very smart people, and they like to get involved, and they like to listen, and they want to learn about the OT side just as much as I want to learn about the IT side. So getting them involved early was very important. Getting them hands-on stuff to work with. It's one thing to explain to them over a Skype call, oh, you can't do this or you can't do that, but to give them a simulation system that they can play with and kind of test those theories out, that's really the key. Cross-training both groups in each environment is also key. I'm willing to learn about IT side, so I can understand from their point of view. They have a completely different point of view. So, and share successes across your organization, especially if you're a large organization. Biogen has sites in Raleigh, North Carolina, where I am, Boston, all over the globe. And, for things like this, you don't want to reinvent the wheel at every site. You want to share that with your colleagues at every site so that as you keep doing projects like these, you can improve, so every time it gets easier and easier, and everybody kind of learns, your entire organization kind of learns from that. Okay, that's everything I had. Thank you.